Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, state where possible vector parametric and symmetric equations for each of the following lines. So let's start with the first line, the line passing through points X and O. Let's start by finding the vector equation of the line. We can write the general equation of a line in vector form. In this equation, vector r represents position vector of an unknown point that lies on the line. Vector r naught represents position vector of a known point that lies on the line. T is the parameter and it can be any real number, and vector m is the direction vector of the line. Now we are given that the line passes through points X and O, so we can use point O for the position vector R0. Since all three components of this vector are equal to 0, so this is a 0 vector. Now we can find the direction vector of the line, and for that we'll have to subtract the position vector of the 2 points that lie on the line. Since one of the given points is the origin, so the direction vector of the line will be the position vector of point X. It is equal to the point X. Now we can write the vector equation of the line. Since vector R0 is a 0 vector, we can ignore it. We do not have to show it in the answer. So this is the vector equation of the first line. Now we can write the parametric equations. So let's use point X, Y, and Z as an unknown point that lies on the line. Now we can write the X, Y, and Z equations. So we'll multiply the components of the direction vector by t. For the X equation, we'll use the X component. Now we can write the Y equation. So we use the Y component, and now we can write the Z equation using the Z component. So these are the parametric equations of the line. Now we can write the symmetric equation, and for that we'll have to isolate t from x, y, and z equations. So let's start with the x equation. We can isolate t by dividing both sides by -4. So this is the expression for t from the x equation. Now we can do the same for the y equation. So I get t equals y over 3. The z equation has no t term. That means we cannot write the z part of the equation in symmetric form. We'll keep it in the parametric form. So our equation in symmetric form is So this should be the symmetric equation for the first line. Now we can analyze the second line. The second line passing through point Q and parallel to the z-axis. So let's start with the vector equation. For position vector r0, we can use the given point Q. This line is parallel to the z-axis, so the direction vector for this line can be 0, 0, 1. So this is a very important concept we need to understand and memorize. Now we can write the equation in vector form. Next, we can write the parametric equation for this line, and for that we'll have to use point xyz as an unknown point that lies on the line. Now we can break up this vector equation to write the parametric equations. So let's start with the x equation. We should use the x components of the three vectors, and we should multiply the components of the direction vector 0, 0, 1 by t. T times 0 is 0, so we can ignore the term. Now we can write the y equation, and for that we'll use the y components of these three vectors. T times 0 is 0, so we can ignore that term. So the y equation is y equals 2. Now we can write the z equation. We should use the z components. So these are the parametric equations for this line. Now we can write the symmetric equation. Now for this line, the direction vector is 0, 0, 1. Two components of this vector are equal to 0. That means we cannot write a symmetric equation for this line. So we can explain our answer as so this can be the final answer for the symmetric equation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.